Number 11. The distribution of the diameters of ball bearings made under a given manufacturing process is normally distributed with a mean of 4 centimeters and a standard deviation of 0.2 centimeters. What proportion of the ball bearings will have a diameter less than 3.7 centimeters? Alright, so this term normally distributed right here is really important for us. This is what our normal distribution looks like. So we're going to be using the calculator to help us solve this, but first let's draw in some things on the normal distribution. So it's given that the mean is 4 centimeters, and in our picture that'll go right in the center. We also know the standard deviation is 0.2, so if we want one standard deviation away, we would add 0.2 and subtract 0.2 to give us these two standard deviations away from our mean, these two slots right here. And if we want 2 standard deviations away, then we'll add 0.2 again to 4.2 and subtract 0.2 from 3.8, and we'll get these two. And we can keep going with standard deviations, but usually we stop at 2 or 3. Now let's put 3.7. Where would 3.7 go in our picture? Well, it makes sense that it would go between 3.6 and 3.8, right here. And we know that we want to find the proportion of the ball bearings that will have a diameter less than 3.7. So in your picture, you should shade either to the right or to the left. In our case, we're going to shade to the left because we're less than 3.7. So this shows all the space that's less than 3.7. Now we're going to bring in the calculator to help us with this. Okay, so we have our calculator. This term normally distributed will also help us remember what to do with the calculator because we want to do distribution. We're going to go second where it says vars for variables. Above it in blue it says distribution. We're going to click that. Then we're going to go to normal CDF. So it might be different on your calculator, but on most of the calculators that we have, this is what you'll see. Lower, upper, mu, sigma, and paste. So the lower bound is exactly what it sounds like, the lower bound, the smaller number that we're going to. So in this case, since we're less than 3.7, we're actually going to the left forever. But the smallest thing you can have is 0, so 0 will make sense for us. You can leave it as -1 times 10 to the 99th if you want, but 0 also makes sense within the context of the problem. Our upper bound will be 3.7. That's our right bound here, 3.7. Mu, we should know, stands for mean. The mean was given to us as 4 centimeters, and the standard deviation was also given as 0.2. We paste it, hit enter again, and we get our probability, or our proportion, 0.06680. So it's not our favorite choice, but it's a pretty good one because it's correct. Our final answer is choice 1.